Hey, hello guys. Hope you guys are doing good. So I'm started this channel called ML Made Easy. So the main motive of this channel is like to deliver the machine learning concepts to the students or who are starting their machine learning and data science journey. Uh, so what you can expect from this channel is like all the concepts will be delivered in a layman language, in the sense like everything will be stick to the basics, and instead of going into the math intuition, I'll try to explain everything from the concepts, and also I'll be taking the math intuition wherever required, and that too very limited there, so that people will not get confused instead of going into deep equations. I will also try to explain the equations that are whichever necessary, and also I'll try to take references from the industry people, and I'll cover those concepts into this as well. So welcome guys, welcome to my first video. So in this video, I was planning to talk about linear regression. So hope you guys know a little bit of machine learning. Uh, the first video that I'm gonna make is linear regression. So let's start. Before going into the linear regression, first let me explain what you can expect from this video. First thing is what is machine learning. I will be explaining what is machine learning, then different models that are in uh, in machine learning, and what's the emphasis of linear regression, and what are the topics that are we're gonna discuss in linear regression. The topics that we are gonna see in this is like what is linear regression, then practical example. Oops. So what is linear regression and example, then little bit of math, and fourth one would be like what are the equations that are present, and everything I'll try to explain like I assume no the viewers that are seeing this video has no knowledge about machine learning or whatsoever, so that I'll keep my things small and examples very simple. So, and I'll also keep the video very short. So, what is linear regression? So, before that, what is machine learning? Machine learning is nothing but it's a small kid, or like uh, teaching and mission to what to do, what the humans does. For instance, let's say if you have an image of cats and dogs, like if you wanna teach to a small kid who has just born, what do you do? First, you give the show him a lot of cats and dogs, right? Show him what is cat, this is dog, this is cat, this is dog. And then out of nowhere, we'll show him some different image and I'll ask him, what is this? Then he will say, it's a cat or it's a dog. And if he makes error, he will rectify it, right? So that's how the machine learning also works, the similar way. So there will be different, for instance, let's say you can take these models as different teachers, like they will teach their models different, oh, sorry, different kids, like each kid has different capacity of learning, right? So these models have different parameters, they have different things to do. Each model has his own importance. So in this video, we'll be addressing about linear regression. So coming to linear regression in the sense like you are predicting something numerical in the sense like let me um, explain with an example. So, for instance, let's say you have height of a person, you're gonna predict weight of the person. For instance, let's take a generic example. So here you can see every person has different heights, and you by basic knowledge, like every based on the height, weight also changes, right? For instance, let's say someone who is 100 centimeters will be of course more weight than 50 centimeter guy. That's obvious, but there will be some outliers too. I'm not saying there will be outliers, but this is a general pattern that we know by seeing, right? So I took this example. So we can just say the height is proportional to weight. So we are taking that concept and there is some proportionality, that height is proportional to weight. So what you're gonna do is, like, you're gonna put this into math and see, so for instance, let's say someone comes and says his height is uh, 80 centimeters. So we are gonna teach a kid that if he is 80 centimeters, what is height weight? So our model will predict. The kid will say, okay, his weight is gonna be somewhere in between this, somewhere around 60 kgs. So that's what we're trying to build here. We're trying to make use of this relationship and putting into an putting into an math and creating a model. So let's go into the next slide so that you will get more uh, understanding. So if you can see, I just plotted these heights and weights into an two-dimensional graph. The So as we can see, there is an linear relationship, right? See, weight is increasing, height is also increasing. What we wanna do is you gonna fit a straight line among all these points, which passes through these points. So this straight line equation, I hope all we know, y is equal to mx plus c. Uh, y is equal to mx plus c. So what you're gonna do is you're gonna predict a straight line. Predict in the sense like you're gonna fit a straight line or draw a straight line which passes through all these points. And whenever we get a new point, for instance, whenever we get a new data point of weight somewhere 60 kgs, so this equation says the weight should be somewhere here. That's what we're trying to do. That's what linear regression is about. Okay, so all our task is to draw this simple line. All our task is to draw this simple line. How hard that could be. So let's discuss how we're gonna draw a linear line. Okay, so we all know that the equation of a straight line is y is equal to mx plus c. So uh, in normal terms, m is slope and c is oh sorry, m is slope and c is gonna be intercept, right? So I'll also explain what is slope and what is intercept. So let's explain what is slope first. So slope in the sense, for instance, take two straight lines. These two are straight lines, but they have different slope. Slope in the sense, if how much is this straight line is gonna change when there is a unit change in the x direction, there will be a unit change in the y direction as well. So how much is it gonna be? For instance, let's say there is a unit distance from 2 to 3. This is gonna be 4 to 6. So slope is nothing but what is the change when in the x direction, when there was a 1 unit of change in the x direction, how much is the change gonna be in y direction? So to do the math, 6 minus 4 divided by 3 minus 2 gives us the slope in the sense like 2 by 1. So if we change x in 1 point, then y is gonna change 2 points. But for this, uh, but whereas for this line, uh, it has different angle in the sense like it has different slope. You can see this for 1 unit of change, it has more. It is like is more towards up direction in the sense like it has around 4 units for 1 unit. You can clearly see this based on the slope. So that's what slope is about. So when you put the slope here, it will become a straight line. You can build a straight line by using all these three: data point and intercept and slope. So our task is to find these three things: theta naught, theta 1. So, you guys might be wondering what is the difference between these two. It's the same thing, but written in a different language kind of thing. So, most of the statisticians try to come up with this uh, concept called hypothesis. So we'll talk later about all these hypotheses. So hypothesis is represented by h theta of x plus intercept plus slope into x. That's what a linear regression equation is about. Now our task is to see. Oh, sorry, I forgot to explain about intercept. Intercept is nothing but when there is when the oh, there's another terminology that we can I can also say that this is called independent variable in the sense like it is not dependent on anything. Oh, sorry guys. So this is height, this is weight. Sorry for that. This is height, this is weight in the sense like whenever the height is increasing, the weight is gonna increase. Uh, so what were I'm saying? Oh, I'm talking about the intercept, right? Whenever the intercept is zero, in the sense like whenever the independent variable is zero, oh, then what is the value of dependent variable? Is not, you can put it here as when you substitute the value of zero, h theta of x plus theta naught plus zero into theta 1. So it's theta naught basically, in the sense like y value is wherever, in the other terms, where is the lines gonna start? In the sense like this, where is this line gonna touch the y-axis in simple terms? Somewhere around here. I might drawn this straight line a little bit wrong. So it's obvious that whenever the height is zero, the weight is gonna be zero, right? So something like that. So whenever you go into deep, you'll have better understanding. So now our objective is to find what is theta 1, how to find this slope, how to fit this straight line. So there are basically two approaches in solving this parameter. This is called a parameter. Theta 1 is called weight of the equation. So we are gonna find that. It's you guys don't need to worry about slope and weight. So it's like in simple terms slope, but in most of the machine learning it will be addressed as a weight because it is a parameter that we need to find out. So to find this weight, there are two ways to solve any machine learning model. One is um, iterative, one is iterative solution, and other is closed form solution. So what is iterative, what is closed form solution? So iterative solution is first you find some weights and you will modify that weights, modify it until you find the best weight that fits our data, best line that fits our data in the sense. So let me explain. So it's gonna be first you gonna fit some straight line like this, then you will see the error of data, then you'll optimize it. So you'll until you get the best fit line, you will be using hit and trail method to find out the best fit line. So that's what you're gonna do. That is iterative solution. Closed form solution is nothing but within one straight approach you'll find the best fit line. That is called closed form solution. So in this video, due to the time constraint, I'll be covering only iterative solution. But if you guys want to have the closed form solution as well, if you guys you can comment down below, I'll try to cover it in a different video. So other one would be the loss. Okay, so there should be always metric, right? So to see how our best model is gonna predict, in the sense like how well is our kid is gonna predict. Okay, so error or loss is nothing but if you give the input of height 50 centimeters, I'll show you here. So for this height Uh, how much is it's gonna be? This is like 40 kgs, right? This is 40 kgs. Sorry, this is 40 kgs. So our kid is just predicting as 38 kgs. So there's an error of 2 kgs. So there's always gonna be error. No machine learning model is ever perfect. I saw somewhere on LinkedIn that someone was saying that no machine learning, no ML model is ever perfect. It's all about which one is the best model, in the sense like which one is giving best accurate results, in the sense like which is performing better when compared to others. Okay, so that's what we are trying to do. What we're gonna do is like we'll find the more best fit line which has less error, like less amount of deviation. For instance, let's say uh, there was a line like this. Okay, so but our point is here, but the prediction is here. So it's like for example, you got error as 5 kgs. Based on this best fit line, you'll get 5 kgs of error, which is bad, right? You're gonna choose this 2 kgs. So that's what you're trying to find out, which line has gives the best predictions. So that is called error or loss, real minus predicted. And there's also a concept of cost function. So cost function is nothing but I was telling about the error, right? I was telling about the error for this point. So then for this point, for instance, let's say there will be multiple points that will be checked. In the sense like for 30k, for 30 centimeter kid, for 50 centimeter kid, 24 centimeter kid, something like that. You'll have a big data point, and all these errors will be getting. For instance, let's say the original answer is 28 centimeter, original answer is 50 centimeter, 24 centimeter. So the difference is 2 centimeter, the difference is 0, the difference is 2, something like this. Then you gonna add all of these to give the overall prediction, overall performance of the model. That is called a cost function, that is represented by cost function. So the so what oh, that's that's what is happening. You might get confused about by seeing all the squares by n and the summation and all. So let me explain in a simple terms. So what happens is you do the in the sense like you take the difference. Sometimes the point might be up, sometimes the point may be low. So by using that formula, it gives plus 2 or minus 2, but it doesn't matter for us. It's error. Plus 2 or minus 2, it doesn't matter for us. If you square it, you'll get minus 4. That's what we need. 4 in the sense like um, you are not worrying about the sign. You just need the unit 2. So that's what for that you will be squaring it. So you need not worry about the magnitude, because every time it's gonna be comparison between this this line and this line. So there's gonna be comparison, and you're gonna find the best one out of it. So you did not worry about it, about the magnitude. That's what I'm trying to say. Okay. So why did you use 1 by n? So what happens is there will be some differentiation happens. So at the time of differentiation, so basically what you're trying to do is trying taking to mean of this all this. So next things next. So how are things gonna be in the iterative solution? So first is like y is equal to theta naught plus theta 1 x, right? First uh, first you will be having this theta naught. Uh, this will be uh, assigned by using domain knowledge, or like there are some mathematical methods. I'll also explain that in the next future further videos. So For instance, let's say how in the domain knowledge. For instance, let's say our problem is height and weight, right? So if the height is 0, what's gonna be the weight? So it's obvious, it's 0. So 0 plus theta 1 into x is equal to y. So this uh, this is our equation as of now. So first but now we are using iterative approach. First we will be assigning some random values to this weight. Theta 1 is equal to, for instance, let's say it's 5. We'll just give a random value. That's what it's about. We'll take a random value, then we'll see the error between the original point and the predicted point, and we'll try to decrease this error, whichever is working. Then you'll go to the next point 4, next 3, 2, somewhere around this. Then you'll see which one is working fine, and then you'll choose it and you'll finalize the theta. Theta is equal to, for instance, 4 is working fine, then you'll finalize it. That's what we're gonna do. But it's not that simple, in the sense like that's the basic thing which is going on, but we'll try to do it in an optimized way. For instance, let's say you can't go for every random number and check it, right? But we'll go into a specific manner. So that's what it's gonna be happen. That is called gradient descent. The concept of gradient descent comes here. Gradient descent is everywhere, in the sense like in every most of the machine learning models, it's gradient descent is there, mainly deep learning and all. So we'll be discussing all those things. Uh, so coming to gradient descent, uh, so first you assign the value as 5, right? So you might get some error. This is it's a plot between theta and j naught j theta. In the sense, this is the cost function value, the overall error of the model, and the theta value. So the error might be in the sense like if the theta is 5, for instance, let's say the theta is 5, the theta is somewhere around here 5, the error is somewhere 20. You, your objective is to find the value of theta where you get the cost error as the minimum, the lowest. Okay, so what you're gonna do is uh, you'll try to find somewhere down theta 1, theta 2 is equal to 4, then you'll get somewhere around 15, something like that. You'll plot that function, so every time it comes like in this curved shape. So you kind of come down, your objective is to come down and go to this position. So in mathematical notation, you're gonna explain it in a way, this old one minus alpha into change of the slope. You everywhere you'll go here, you'll stand here and see how's this direction. For instance, let's say the error is 20, here the error is 10. Okay, so it's gonna be like this. This one I wrote here. Uh, this is 20, this is 10, and the value of here is 4, here is 5. In the sense like now you're gonna find the slope of it. 20 minus 10 divided by change in 4 minus 5 minus 4. So it's gonna be 10 by 1. So after an unit change in theta from uh, 5 to 4, oh sorry, so it's the same thing. The J2 is 10, J1 is 20, theta 1 is uh, the theta 1 is 5, theta 2 is 4. Okay, now you do the math. 10 minus 20 divided by 4 minus 5. So it's gonna be minus 10 by minus 1. So For unit change, it's 10, right? So you'll change the theta value because like the j theta is getting decreased. The j theta is getting decreased if you decrease the value of theta. So you're gonna come in this direction slowly, slowly. So by you use this concept of convergence theorem where you'll find the new value of theta of the whole value of the theta minus alpha into change in value in a sense like 10. So what is this alpha? Alpha is called learning parameter. It's called learning parameter in the sense like you don't want to do this, like you don't want to do step by step, you want to do really slow, because sometimes what happens is these values might be big. You could have jumped from right from there to here, from right from there to here, like this. You will get into an endless loop. You just want to do slowly, and not that too slowly also, like you want to do step by step, step by step, step by step, and come here. Sometimes you'll be stuck here. Then no, in the sense like your random value might give the cost value there. Then you're gonna come down slowly, slowly, slowly. Then that's your objective. uh, so I hope I explained gradient descent decently. So let me know if you have any queries. Like I think you guys need a different video on concept of gradient descent because it's a very big topic. I could explain it with a better example, but I'll try to do that in a different video to explain about linear regression. I'll try to stick to a little bit of basics. Um, so that's what, like, we came to the end of the video. Oh, hope you guys liked it so far. So I'll wrap up with what are the different things that are present. So what happens is like you will try to based on this values, based on this cost, and theta, something like this. So if the theta value is 3, the cost is 40. For instance, let's say like if you do the math and everything, you got some, I'm taking some random values. So if theta value is 4, then the value is 20. So you're gonna obviously choose 4, right? And make a best fit line, and you'll draw a best fit line, and you'll keep this model into the industry. So which one is giving the less value? So every new data points will be predicted using this parameters. That's your end goal. That's what you guys address this situation. So now coming to different models, like simple linear regression is like it has a lot of things to discuss. One is like simple linear regression, which we just discussed, in the sense like it has only one independent variable. It has only one independent and one slope. It's called simple linear regression. Then if you, in the most of the cases, it won't be that. For explaining the concept and all, I used simple linear regression, but in real world situation there will be multiple independent variables. For instance, let's say you are predicting the price of house. So house value will be used by um, is predicted by a lot of parameters. For instance, let's say broker fee, and like supplies fee and man work, and all these things will be taken into construction, into deciding parameters, right? So all this will be taken. So each parameter has its own weight. For instance, let's say this is uh, like supplies money. This might be like land price. Based on all these, you'll find the final price. That's what multiple linear regression is about. And coming to polynomial linear regression, so we have assumed that there was some linear, in the sense like straight line relationship between the independent and dependent, right? So sometimes it's not like that. Sometimes it's gonna be, sometimes the points are very reluctant. So sometimes what happens is there might be something like this, or like curved relationship like this, something like that. So you need a curve instead of straight line. So to address those things, polynomial linear regression comes into the concept. Basically the same thing, but instead of power 1, you'll get power 2. That's it. The same thing. So after doing all this, there will be some model metrics, and they will calculate all the errors and how well our model is doing. So that's what is about linear regression. So guys, please comment down if you find any doubts in this thing, and also like if you guys liked my explanation, please comment down below. And also like if you guys need any additional topics, please let me know. I'll try my level best. Like I'm planning to do every video on every Friday. This thing today I explained about linear regression. I'm planning of explaining what is data science, what is machine learning, what is AI, and all these things I'll cover in next video. That's what I was thinking. So please let me know. Oh, thank you for watching.